Hey, we've got lesson number 17 here. We are relating scale drawings to ratios and rates. What does that mean? An old friend comes back to visit us, people. It's the constant. Yes, welcome back. The constant is here again. All right, so we just give it different vocabulary words. All right, so when we are dealing with our friend constant, let's see how it kind of shows up here. So let's kind of go down the page, go down the page. All right, here we go. So we're dealing with our scale drawings here, and our constant is also going to be known as what's called a scale factor. And that's what's going to allow things to make things bigger or smaller that's there. So we got Emma here. She drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. Okay, so the coordinates, no thank you. Let's just find the length here that we're dealing with here. So the lengths of the original drawing. We're dealing with rectangles here, which means we just need a length and we just need a width. That's it. Yeah, we don't need to figure out all the points. So let's just count, all right? Here I'm at a 7, all right? At 10, 11, 12, we're at a 13. How far to get from a 7 to a 13? Well, that would make a 6, all right? All right. And then let's see here. We're down at a 0. We're going all the way up to a 15, 16, 17, all the way up to an 18. There we go. 6 by 18 we're looking at. Let's check the second drawing that's there. What I do have to do is I have to stay in the same pattern. So because my first measurement was my width, going left to right, I need to do the same thing here. So if I count, I'm going from a 7 to a 10, so it's a 3, all right? If I'm going up now, all right, I'm down at that 0, going all the way up to a 9. Okay, so how are the scale drawings related to ratios, rates and ratios? Okay, so things that we want to see here is we can think of as fractions. There is my original. There is my second. And remember, this was my width. This was my length. All right. Oops, hold on a second here. Hold on. Whoa, wait a second. No, it wasn't. All right. We kept the width, all right, with the width, and then we kept the, over here, we kept the length with the length. You see, the thing about your setup is it doesn't matter as long as you are consistent. And what we can see here is, yay, times it by 3, whee, all right? If I organized it differently, so if I took my original one and did the width and the length, and we'd stay consistent, and we do the width and the length, well, check it out. Divide by 2. We're still getting a proportion that's there. So that's going to be fine. That's not going to make a difference in this. So are the pairs of corresponding lengths proportional? Yes, they are. All right. And again, that's because we're multiplying by the same number. I didn't need to use cross products here. I mean, I could use cross products. But we tend to save that when we don't know what we are solving for. So what needs to exist in order for an image to be considered a scale drawing? Well, what needs to exist? We are going to need a constant, which means we need it to be proportional, which means we need equivalent ratios. They're all synonyms that are there. So what is the constant of proportionality? Now, this is where we have to be a little bit more consistent. If we kind of go back up, we have to keep in mind is, what am I doing to get from one drawing to the other drawing? So I can't use the 6 going to the 18. That's both from the same drawing. I've got to think about, what did you do to get from there to there? All right. So that's what we want to watch for. So remember, that was my 6 to get to my 3. What did you do? Okay, well, we got smaller. What do you do to a 6 to get to a 3? We divide by 2. Now, here's the thing, though. Constants, it's always a multiplication problem. It's what you multiply by. Again, let's go back in time. Remember our friend y equals kx? Yes, it's what you're multiplying by. So even though I'm saying I'm dividing by 2, dividing by the 2 is the same as multiplying by Yes, a half. Right. So our constant is a 1/2. So we do want to keep that in mind. Really what we're looking at here is, did you get bigger or did you get smaller? Got smaller. So that means it's going to be a fraction. It's going to be smaller than 1. So if you're ever like, is it 2? Is it 1/2? When I flip it around, which one is it? Well, if you got bigger, your constant's going to be bigger than 1. If you got smaller, it's going to be smaller than 1 there. So is it a reduction or enlargement? Yeah, it's a reduction. It got smaller. That's there. All right. Let's take a look at what we've got going on here. Very similar from that standpoint. The original drawing. So I went from a 5 to get to an 8. So that was a width of 3. And then I started down at a 0. I went up to a 5. So there we go. Again, got to stay consistent. So going left to right from a 5 to a 15, that's a 10. And then from a 0 up to the 15, that gives me a 15 that we're looking at. So what we're looking at here, hold on a second, hold on, I want to make sure, 1, 2, 3, yep, all right. Set up a ratio of the corresponding sides. So, again, I'm going to match things up. So I like to we'll do the length, all right, and then the widths, and we'll keep things the same. So the length of the first one was a 3, all right. The length of the second one, all right, was a 10, or I should say the width that I was using. I'm gonna change. I'm gonna be a little bit more consistent here. Let me. I said the width. Typically, the width is what goes from left to right. We're talking about how wide something is. The length is our up and down. So our up and down of the first drawing was our 5. The up and down for the next one was our 15. So, are the corresponding lengths proportional? And here we're going to say a flat out, no, they're not. All right. Now, how do we know that? Well, we, like before, know constants, all right? So remember, proportional, you're going to need a constant. I can look at it as, hey, I multiply by a 3, but I don't multiply by a 3 up here. I could do my cross products. 15 times 3 is a 45, but 5 times 10 is a 50. So yeah, we're not there. So would Williams' image of the original mosaic be considered scale drawing? No. All right, and again, why not? Again, we're back at the idea of no constants, all right? So is it more of an enlargement or a reduction? Well, yeah, it is an enlargement, but again, it's not proportional with it. So, yeah, so we're going to be very visual here. Our constant comes out in keeping things organized. And again, focusing on going from the width to the width, all right? Focus on going from that length, that up and down, to that length of going up and down over here as well is what we are after. All right, people. 18's going to get into a lot of what we just saw here. So we'll see another day's worth of it as well as a little bit of a preview from that standpoint. But yeah, we're visual. We are drawing that's here. Good times, people. Good times that we are after. So with all that, we say goodbye to you. All right. It's nap time, people. We'll see you.